Hi, this week we're going to talk about denial of service attacks. We're going to understand how a denial of a service attack occurs, and we're going to understand what we can do to defend against them. So, in order to really talk about denial of a service attacks, we have to understand how connections are made between a client and a server. So, for example, when you sign on from your computer to Canvas, you're going from your client computer to the server where Canvas is stored, just to give kind of some context. This connection is called a three-way handshake, and this is how it starts. So in this example, we have somebody, his name is Bill, and he wants to get some data with Sheila. And it could be a database, for example, would be a better example. So the first thing is computer A, Bill, initiates a connection to the server via a packet with something called a SYN flag. The SYN flag is sent. So, it checks to see if the port is open, and it sends this SYN flag. The server then replies with a packet with both the SYN flag saying, yes, my port is open, and an acknowledgement flag set. So there's two flags now that the server sends back. The final step is that the client responds back to the server with an acknowledgement, saying it received the SYN and it received the acknowledgement, and now it acknowledges it and goes forward. It's only when these three steps are completed that an actual TCP connection is established between the client and the server. Any disruption of any one of these steps will prevent the connection to occur. So there's lots of things that can happen here. So let's talk about it. One of the most common attempts for a DOS attack is to try to send too many requests to the server and to prevent legitimate users from being able to access it, because you flood the server with so many requests that it overloads the server. Because you have to remember, computers have physical limitations. They're limited by the number of users, the size of the files, the speed of the transmission, and the amount of data stored. If you exceed any one of these, you will cause the server, not to be able to respond. It'll come to a standstill. So there's lots of tools for conducting these attacks. And I'm going to tell you right away, you're asking, why would these tools be out there on the internet? Well, one of the reasons is that these tools are used by network administrators to be able to do what we call stress test, to make sure that we're able to process the number of requests that need to be legitimately processed. So one of these tools is called LOEC, and I have a super video that'll show you how it's used, but you can get this from the internet for free. It's GUI, you're looking at it here. It's easy to use. You put in an IP address where you want to go. You identify how long you're going to have the system wait. You're going to identify the size of the packet. You do all of these things, and it will test the system. What it can also do is bring your system down, because you can overload it and make it too big. Another type of attack for these DOS attacks, which is denial of service, not DOS like old-time DOS, is this tribal flood network. It's TFN. And actually there's this TFN2K, which is a newer version. And the reason this is important is because this one can perform multiple types of attacks. It can perform UDP, user datagram protocol attacks. It can do ICMF, the Internet Control Message Protocol, which you remember is messages sent by the server about error messages that the server might incorporate. TCP protocol attacks. So all of these type of attacks can be done by this one type. And what happens is a master controls agents. So it's kind of like there is a person who is the hacker, and they will control what I call slave computers. And they tell these agents or slave computers to designate certain targets send messages to certain targets. This one is important because the communications are encrypted. Encryption is important. If you are an attacker, you want these messages to be encrypted because you do not want your IP address to be identified. And the communications can be hidden in between real traffic. So that makes it, really difficult for the server to interpret which is a legitimate piece of communication and which one isn't. And the master, the actual attacker, can spoof its IP address. So it can use somebody else's IP address. So you can see the communications are encrypted, they can be hidden in real traffic, and the actual attacker can spoof its IP address. So these are very detrimental types of attacks. Another tool that can be used for a DOS attack is a Stratenheim, which means German. It's a German word for wire barrier, and it too is useful because it enables spoofing, but it also will detect spoofing. So you can see it has multiple benefits. It's also called, spoofing is also called source address forgery. So if you ever hear that term, just know it's spoofing. But this one too can perform a variety of attacks with different protocols, and that's what I mean by a variety of flood attacks. Remember, protocols, there's FTP is a protocol, email is a protocol, TCP/IP is a protocol. So it can do many of these, and it can automatically update those slave or agent computers to do other things. So, this tool can kind of adapt a little bit. The flood must be sustained. In order for a DOS attack to be useful, the flood has to continually be going at that server all the time. And because once the machines are disinfected, with antivirus, that's what they mean by disinfecting. With antivirus, the attack stops. And then the hacker's own machine is at risk of discovery. So TCP sync flood attacks is the most common. And as we know, we just talked about that three-way handshake. The sync, this SYN is short for synchronize. And what happens is the hacker sends out, a request, a SYN packet. The receiver, the server, has to hold some space when it receives this particular packet. But if the SYN is not bogus, if it's not something that can be validated, the server is continually to hold all of this, and the buffer overflows. When the buffer overflows, there's not room for other people to get at it. So here is an example here. Here is all these fake packet attacks. And see what happens. Here's the server. And the server is listening, and it's saving all this room for all these attacks. So the real request comes in from somebody else, and you can see it has to wait. And these things often will time out. So what it does is it brings down the server. Because remember, a DOS attack is really about preventing others from using or accessing the server. It's about bringing it down. It's not about getting into it, but bringing it down. So how do you protect against these? How to protect against DOS attacks? Well, a microblock is one method. And what that is that only, if you remember from the last slide, there was these segments that were saved on a server. So if you're using microblocks, you're only saving a very small part of the server, of the buffer. And unless the whole you're able to validate completely, then you don't, that request is going to have to wait till there's a bigger buffer available. This method isn't used very often, and one of the reasons is it's very intensive, because it has to interrogate the information twice. Another one is SYN cookies. And in this one, no buffer is created at all. So a request goes out to the server, no buffer is created. The client response is verified by a cookie. So the server sends a cookie back. And only then after the client sends the information required through what the cookie is asking, is the buffer created. The problem with this one, just like the last one, is it's very resource intensive, much more than even the last one, because it has to send a cookie out, and then it has to, the client will send the information back that the cookie wants. So that's like 2 types of validation before actually the data request becomes available. So this is called a SYN cookie, but it is very effective. Another one is RST cookies. And an RST cookie, what the server does is, remember, the client sends a SYN to the server. Well, the server then sends a SYN and an acknowledgement back. But what the server does is the server sends a false SYN and acknowledge back to the attacker. And then the client tells, if it's a real request, the client will tell the server, oh, something is wrong. And the server will receive this error message and know, that was legitimate, and then it will accept the message. So this is kind of a backwards approach to being able to validate whether or not, because it's the client is telling the server something is wrong. It's not compatible with older version of Windows. Now for us, we think, who's using Windows 95 anymore? But there are some people out there in the world that still are, but it is easier to implement. Now, stack tweeting is another method to protect against DOS attacks. And stack tweeting is quite complicated. It requires the server to time out much quicker. And when that happens, the attack becomes difficult. Not impossible, but difficult, because that means then they just keep sending more and more requests faster because it's timing out quicker. It's also a way to reprioritize which items the server will act upon. That's why it's called stack tweeting. Which ones go to the top of the server list for processing. So these examples so far have been like one client going to the server. In reality, that type of attack is not what's really happening. Instead, we have multiple clients going to the server to try to bring it down. And what we have is a master who tries to control multiple agents, or a master slave, where there's a master and controlling multiple computers underneath them. And one of the ones is very common is a Smurf attack. And the first thing to note is, for a Smurf attack to occur, it has to begin with somebody infiltrating a network, all right? And how do you infiltrate a network? That means some user in the network community has clicked on an email that has a virus or a Trojan horse. Human error is the #1 way that we start this process. And what happens is, once that occurs, the hacker uses that particular computer that's been affected to either go through the address list, and when they do that, it sends out, messages to everybody with targeting an IP, one specific IP address. So if we go to the next slide here, this shows us how. So the attacker sends a packet with a spoofed IP address to some intermediary, somebody who's clicked on it. And that person then sends responses to all of the people in the network, utilizing it. It could go after one server, it could go after one computer, but it attacks one single person, and it's coming from in the network. And the tricky part is the IP address of the attacker is masked, and the IP address of the intermediary is the one that is being used for all of this communication to the victim. The victim can, like I said, the victim can be one solo computer, but most likely it's a server with data on it. So how do you protect against Smurfs? Well, you guard against Trojans. You have adequate antivirus. Education of users is critical. You could use a proxy server so that you don't. So remember, a proxy server changes the external IP address when going out to the internet. For an internal organization, utilize proxy servers, and ensure routers don't forward these internet control messages as broadcast messages to everybody, because those messages bring down the system. Okay, DOS attacks, UDP floods. This is a very common type of attack. The hacker sends these UDP packets to random ports, and what they do is they look to see which port is open. So on a server, there are certain ports that are set. For example, port 21 is set for FTPs. That's a common port. Port 25 is set for email, for example. So a hacker is going to send UDPs to random ports looking for an open port. It generates illegitimate packets, causing the system to tie up resources, meaning they have to look at them, see if they're real, and they back up the packets, and the next thing you know, there's like this flood. It can't get through. It slows the system down. Other types of attacks are ping of death, sending a packet that's too big. This is really not happening all that much unless there's a lot of legitimate requests that look like they're coming in with packets that are too big. A teardrop sends fragments of messages. That means that the acknowledgement can't occur. You know, the SYN and the acknowledgement don't occur right. The server stores, it keeps space for the fragmented message, and eventually it'll time out. But if the timeout is too long, then it just starts to hold up too much space and it brings down the system. And then one is something called the land attack. It's no longer used, but where the forged packet uses the same IP address as the destination. Okay, an echo attack is an echo service sends back whatever it receives. So it combines large amounts of data in the form of an endless loop. So whatever it receives, it sends back, and it continues this process. So what it does is it really ties up the system because the acknowledgement and the SYN continually go back and forth until the timeout. So that's a very popular one. So let's go back. Here we go, sorry. So one important thing about a distributed denial of service, a DDoS, is routers communicate on port 179. That's what they communicate on. And hackers try to trick routers into attacking other targets. So a router-initiated flood of connections with targets will then go to multiple places at one time. So botnets are commonly used to implement this. So for example, here is an example of a botnet attack. Here is the attacker, and this attacker does something to get control of slave computers. So here's all these zombies. So what most likely happened is either this attacker sent a message to one person who clicked on a link, and that link then had a virus, and all the contacts in that person's contact list then became zombies to the attacker. These people don't even know that they're under the influence of this attacker because it doesn't stop them from doing anything that they normally do. They may not even know that they're involved in an attack when it's happening. So what happens is the attacker, and this has a special command, it might have set up something like a logic bomb that at a certain point in time, it wants all of these computers to go and attack this particular server to bring down this infrastructure. And it's using these multiple computers. That's why it's called a distributed denial of a service attack, because it's coming from multiple sources. It's distributed. So some real world examples are MyDoom, where it spread these worked through email, and it caused great chaos. Slammer, which used a worm, memory-resistant worm. It began in 2003, and it was actually aimed at a nuclear power plant. It became dormant, but it has once again kind of resurfaced with a variant. And the thing with it, it's spread without human intervention. It's a worm. It's embedded in some type of code. So how to defend against DOS attacks? Configure your firewall to filter out these ICMP packets, disallow any kind of incoming traffic that doesn't pass the three-way handshake properly, and to use tools like Netstat. And we'll go through those in another chapter in more detail. Don't allow traffic originating within the network, because that means that there can be some problem that somebody got into the network, disallow traffic not originating in the network. Disable all IP broadcast, filter for external and internal IP addresses, keep your antivirus updated, keep your operating system and software patches current, and have an acceptable use policy, meaning, teach people how and when they should click on links and what sites that they can go to and which ones they can't. So that's kind of summarizes our chapter. Thank you so much, and be cautious of denial of a service attacks.